So there's a series of acid derivatives where the carboxylic acid was the original, essentially molecule functional group, but it's been derivatized in some sort of way. An amide is an example of that. So to make an amide, typically we would actually add together an ammonia group or an amine group, so say something like this, and a carboxylic acid. So if I were to do something like this, I have two carbons here. This is an ethanoic acid. Here I just have ammonia. And when these two combine together, one of these hydrogens in this OH group leave. It's a condensation reaction. And they will form a new compound that looks just like this. So when we look at amides and when we similarly look at esters, we can essentially look at them as splitting down the middle here of this molecule. This was the acid side of the molecule. This was the amine, or in the case of an ester, the alcohol side of the molecule. And so this side, the acid side, gets the priority name. It gets the parent chain name. So no matter how long this side is, it could be 12 carbons long and this only has one carbon. This is still the base chain name because it comes from the acid side. So that's the first thing to note for this. Then as we start to add the carbon chain onto this, we can start to see and here we have one carbon, so this is a methane-based group. We have two carbons here, ethane-based group, propane, and butane here as we keep going on. And we'll see how this naming gets affected by that, but it's very, very similar every time. So starting with the very first one, again, we have a methane. And so I'm just going to write down methane because it's the one carbon based on the acid side. There's nothing added on the nitrogen side. So this is a methane, but what I'm going to do is I'm going to get rid of the E. I'm going to call this a methanamide. So one carbon, it's an amide, so I know that there's an NH2 attached to it like this. If there was something else attached to the nitrogen, as in this case, we will see that we'll need to indicate that it's been on the nitrogen. So let's increase the carbon chain to a 2-carbon chain. This is an ethane, so we now call this an ethanamide. Similarly with the 3-carbon chain, propanamide. And finally for the butane, butanamide. So we can see how that goes as we start to indicate or increase the carbon chain on the acid side of the amide or the ester. So now what happens when we start to add on to this side? Well, if we add on to this side, it's actually being added on to the nitrogen. So we need to indicate that it's being added on to the nitrogen. So if we're to continue naming some of these, I'm going to show that if I split down here, this is the acid side. This is a 2-carbon chain. So I have ethanamide is my base chain name, ethanamide. That indicates that I have the nitrogen hanging off of here, so that's part of the amide chain and it's connected to the C double bond O. But what's not indicated is that this methyl group is hanging off the nitrogen. And so we learned in the nitrogen naming series, on the N group is a methyl. So this compound now would be called an N-methyl ethanamide, all one word. The ethane takes into account that it's a 2-carbon chain. The amide indicates that it is this functional group here. And then the N-methyl tells me that on the nitrogen I have a methyl group. So that's how we would incorporate everything into this. So again, naming for the second one here, very similar. I have an ethane chain again. So this is an ethanamide. And now instead of a methyl group, I have an ethyl group. So it's an N-ethyl ethanamide. There's no space here. It just was unfortunate to not combine it together, but there's no space. So N-ethyl. So in the first case here, this was a methyl because it's only one carbon. Now it's an N-ethyl. And similarly over on this side, we're going to see that this is an N-propyl. So I have an N-propyl ethanamide because it's still... Hopefully I spelled it right. Ethanamide. It's a 2-carbon chain on this side, so it's ethanamide, and then the propyl is on the nitrogen side. So it looks like this is the longest carbon chain, but it's the longest carbon chain on the acid side. that is always the highest priority group side that we're going to be dealing with when we deal with these. So like the previous example, we're going to have a long carbon chain on the acid side. 1, 2, 3. This is a propane or it's a propane base chain. And so this is a propanamide, but we need to indicate is that on the nitrogen there are 2 methyls now. So this is an N dimethyl. So in the N position and in the other N position, which is the same one, it's a dimethyl. And this is a propane, and so now we change the name to propanamide. And that covers everything. So the propane and the propanamide is from this side. It tells us we have a 3 carbon chain. It tells us with the amide that that's the functionality. And hanging off the nitrogen are 2 methyl groups. Like that. So that's what finishes that one off. So to clean this up, we'll see the example below it. So also a propane, so we have a propanamide. The only difference is that on the nitrogen we have an ethyl group, and on the nitrogen we have an ethyl group, methyl group, sorry. So E comes before M, ethyl before methyl. So if I were to write this out, I have an N-ethyl, N-methyl. I have to indicate each of these individually because they're different functional groups. And then propanamide. That finishes that one off. And finally, to complicate things a little more, I'm going to erase these here. So we've indicated that the methyl group is on the nitrogen. So in this case here, there's a methyl group on the nitrogen. But what if I had a methyl group hanging off here as well? So I've got a methyl group here, and what if I had a methyl group hanging off here as well? Well, both of them need to be indicated. This would be on a carbon, and this one's on a nitrogen. So this gives us an example of what I'm talking about. So let's take a look at this and see how we can make naming even more complicated. So our base chain name, we're going to start off, figure out the acid side. It's this side here. This is the nitrogen side of things, so the amine side, and this is the acid side here. So we have a carbon chain starting from here, 1, 2, 3, 4. And so now we can see that this is a methyl group hanging off, and this is a hydroxy group hanging off. And on the nitrogen here, we have a methyl group. So first thing I'm going to say is I got a 4 carbon chain. So I'm going to say this is a butane. I'll write it up here. Get it out of the way. And since it's an amide, I'm going to call it a butanamide. So on that butanamide then, I know that in the N position, so I'm going to write it over here just to keep track, I have a methyl group on the nitrogen. So there it is there. But in the 1, 2 position right here, there is also a methyl group. And so you might be used to saying it was a 2,3 dimethyl or an N dimethyl. There's no difference here when we're numbering this. This is going to be an N, 2 dimethyl. So we're going to indicate both of these. So N position, and in the 2 position, it is a dimethyl. I don't have room to put this in. I will rewrite it up top for you. That will look much better. And then I also need to indicate in the 3 position is a hydroxy. So 3 hydroxy NN2. So I need to rewrite this. I'm going to erase this and give myself some space to do it much better, because I didn't do that. So this is a 3 hydroxy N2 dimethyl butanamide. Like that. Whew, that's a long one. All right, and again, the butane indicates the 4 carbon chain. So let me erase all this, start showing what we're naming here, and make sure we get it all. So the 4 carbon chain, 1, 2, 3, 4, that gets covered. The amide functionality gets covered here. The methyl group is hanging off the nitrogen, so that gets covered with a methyl. And in the 2 position here is the other methyl. So it's a dimethyl, and now in the 3 position is this hydroxy group, and everything is covered, and that's how we would name this.